Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 7 of the November Day LeetCode Challenge. And congratulations to all of you who have made it till here. That is, we have completed 1 week here in the November Day LeetCode Challenge. And this is the 7th day here. So congratulations if you have maintained, that is, you have solved all the questions till now. Okay, that is the first thing. Coming to today's question, it is a medium level question. And it is it's related to the topic of bit manipulation, right? So let's see the question. It's really interesting one. If you know if you are experienced in this particular area, that is bit manipulation, if you have solved question previously, I am damn sure that you will find this particular question very easy. Okay, this slight on the easier side, but yeah, if you're not aware of this concept, this is a good chance for you to learn that and to realize its importance. Okay, so coming to today's question, it's 2275, largest combination with bitwise and greater than zero. Okay, large combination with bitwise and greater than zero. Let us see what the question is. So basically, we'll be given a candidate array, which will be an integer array, and return an integer as the output. Okay, so let's see the question now. The bitwise AND of any array nums is the bitwise AND of all the integers in nums. Okay, that is when I say bitwise AND of an array, it means that you have to do the bitwise AND of all the numbers present here. Okay, that is the basic idea. For example, if nums is equal to 1, 5, and 3, and bitwise AND is equal to the bitwise AND is basically equal like this. Okay, this is the AND operator. Basically, if you are not aware of this, let me suggest you this. You can quickly Google what is operator is. Okay, this has something to do with the binary representation. Okay, you'll have to calculate the binary representation of each of the numbers involved, that is each operand involved, and then you have to do the AND operation between each bit here. Okay, it's a bitwise operator. So as simple as that. So I'm doing the bitwise operator here. I'm using them for each of the operands, and finally I'm getting the answer as 1. Also, nums of 7 is equal to 7, and the bitwise AND is 7. Okay, so yeah, if you have a single number, the bitwise AND will be in the same number itself. Okay, as simple as that. You are given an array of positive integer candidates. Okay, evaluate the bitwise AND of every combination of candidates, every combination of numbers of candidates. Each number in candidate may only be used once in each combination. Okay, return the size of the largest combination of candidates with a bitwise AND greater than 0. Okay, so what you have to do, see, you can take any, for example, you can take any, see this, for example, this has around 7 elements. Out of those 7, you can take any number of elements. Okay, and then you have to do bitwise AND. The condition here is the bitwise AND should be positive. Okay, it should not be 0. It could be any number other than 0. Okay, that is the basic idea. It could be any number greater than 0. You have to collect all such combinations, and you have to return the length of the largest such combination possible. Okay, so what we have to do, see, we have to find the bitwise AND of all the combinations here. Okay, whichever element you want you can take, but here we are more concerned with the length of the combination rather than the elements of the combination, right? So we'll have to find all such combinations, and whichever combinations are having a result of bitwise and greater than 0, we'll have to consider them for this, and among them which one has the largest number of elements, that will form my answer. We have to return the length of the largest combination whose bitwise and is greater than 0. I hope you understood the question. Just pause the video, go to 10 to 15 seconds back, and just try to see what I'm saying. I'm damn sure that you will be able to understand after that. Okay, maybe in the second attempt. The thing is very clear. You have to take all such combinations here. Okay, when I say combinations, it could be any element. Okay, any number of elements you can take here. Okay, in such a way that when you calculate the bitwise AND of them, you are getting non-zero answer, and you have to return the length of the such largest combination. Okay, that is the basic idea. First thing is the bitwise AND result should be greater than 0. Second thing is, among all such combinations which are satisfying the first condition, you have to return the largest combination, that is the length of the largest combination you have to return. So in this case, if you see, they have given a combination here, and they are claiming that the bitwise AND of this particular thing is greater than 0. That is fine, and they are also claiming that for this particular candidate array, the answer, that is a length of such combination, cannot be more than 4. Okay, that is more than 4 elements you can never have, such that the bitwise AND result is greater than 0. That is what they're trying to claim. Okay, it can be shown that no combination with a size greater than 4 has a bitwise AND result greater than 0. That's what they're trying to claim, and this is the second example we have. You can see that. Okay, so I'm assuming that, see, if you are a very beginner, okay, let me just give you a quick example of what is a bitwise and we are doing. So for example, if you talk about 8, okay, 8 so looks something like this. Okay, 1 0 0 0, okay, 8 4 2 1. Okay, this is how it looks. Okay, and similarly, if you talk about 1, yeah, if you talk about 1, it looks like this. Okay, all the bits are 0, only the first bit. When I say first bit, means from left. Okay, that is LSB I'm talking about. See, this has a power, so each bit here represents a power, each portion here represents a power. So I'm talking about LSB. Okay, this is 1 in this case, for it this is 1. Okay, if you do AND of them, what will happen? You have to take this 0. Okay, you have, see, B each portion, it will happen with this one and this one. You have to take and you have to do a bitwise AND. Okay, bitwise AND of, okay, non like, that is, if they are different, the numbers are different, the bitwise AND will be 0. As simple as that, right? So similarly, the bitwise AND of 8 and 1 will result into 0, because, see, if you see, none of the terms here have a value which is same in the other term. Okay, Okay, but yeah, the zero zeros are same, but again, zero and then is zero and zero, zero and zero is zero only, right? So the answer will also be zero in that. So but there are no ones for which the corresponding position one is also one. Okay, for that reason, the and of 8 and 1, okay, will be 0. Let me write that also. The and of 8 and 1 is equal to 0. Fine. Now we have got one thing here. What is the AND operation? I am assuming you are knowing that. If you don't know, please Google it. And I'm damn sure you will getting many multiple examples out of that. Okay. You have to run what is a bitwise AND operator, and you have to see some examples, and you will be done with that, right? Now coming to the next question. What we are trying to do, how to solve this question now, right? See, one thing that I want to show here is that, for example, okay, now for the same question, okay, let me convert it to one now. Okay, this becomes 9. Okay, this becomes 9. Okay, so what I'm going to do, let us do an end of 9 and 1. Okay, what you're going to get now, see, whichever position is 1 in both of them, okay, that will be written in the answer also. The answer will have the LHB as 1. Okay, that is what I'm trying to show you. So the answer in this case will be 1 again. Okay, that's what I'm trying to show you. So the idea here is, okay, so the combination that we are going to take, okay, the combination that you're talking about, the combination that we are going to take, what we have to try to see here is that, see, we are only concerned about greater than 0, right? I am not concerned about the actual result of that. Okay, I am here just concerned about what is the result, whether it's greater than 0 or not, only true or false, right? That's the only thing that I need. So if all the elements in these candidates, okay, that is the combination here that I'm talking about, all the elements in that have a bit. Okay, when I say bit, a particular bit in a position have a value of 1, only then this is possible. All their, the final result of the bitwise AND is greater than 0. Why? Because see, here one such bit is this. Okay, in both the numbers, that is in both the numbers in this, let us say this is a combination, 9 and 1 is a combination. So the bitwise result of this will be 1, that is non-zero, because here there is a particular position in which all the elements are having 1. Similarly, if you have more than two elements, here we have two elements, if you have more than two elements also, if there is a particular position in which all the elements are having 1, so okay, then in the final result we will again have 1. That means the answer will be greater than 0 in that case also. So we will have to find out what are all such combinations, okay, in which the number of the combinations and the elements are having more than one positions, okay, one or more positions where all of them are having ones. Okay, so the idea here is basically, see, the if you see the constraints here, okay, it is up to a value of 10 power 5. So to have a 10 power 5 value, how many bits we need first of all? Okay, so I've done a calculation here. Okay, so we have to see like 2 power n, okay, is equal to 10 power 7. Okay, 2 power n basically equals to how many bits we need. Okay, n is the number of bits that we need here. Okay, n is the number of bits that we need. 10 raised to power 7. Okay, yeah, so what I'm doing, I'm just applying log on both sides. Okay, if you apply log 10, log base 10 on the right side, you will get 7 here. Okay, similarly, if you apply log base 10 on the left side, you are getting this and log 2. Okay, and log 2 base 10. Now if you solve this question, you will get this. Okay, n is equal to approximately 24. So basically we need 24 bits to do this. So our answer will be based on that. So what I will do is I will create a bit array, okay, set bit count array, okay, which has a length of 24. That is, I'm trying to see among all the numbers I will go through, and I will go through each of their set bits. Okay, then I will see in which position they are, and accordingly I will update the set bit count array. Okay, I will update the set bit count array. So idea here is, see, I am going through each of the number, right? Each number will have something, a bit representation like this. Okay, for example, in this 9, okay, this particular bit and this particular bit are ones. So I will try to record the same in the this particular array. Okay, so I will say that the LSB, that is the this particular zeroth one and the fourth one, okay, okay, zeroth one and the third one are having ones. That means I will just add one to their zeroth and fourth position here in the set bit count. Similarly, in this I will add a one to the zeroth set bit. Okay, that is the idea. Okay, that's why I've taken 24 bits. Okay, each bit basically, each here element refers to, in my whole candidates array. Okay, how many elements are having that particular bit set. Okay, I hope you understood it. See, in my candidates array, how many numbers are having that particular bit as 1. Okay, that will be referred by this particular bit count of I. So what is bit count of I? It refers to the number of elements in candidates that have the ith bit set to 1. Okay, as simple as that. Okay, so if you want, you can please write it somewhere. That set bit count of I is basically the number of elements in the candidates array who have the ith bit set to 1. As simple as that. Okay, so what I'm going to do next, I will be having two loops now. Okay, the outer loop will be from 0 to 23. The inner loop will be going through all the numbers in the candidates area. What I'm going to do next, I am going to use this particular thing. What is this thing? See, you will have to learn about what is a left shift basically. Okay, so the idea here is, I am through this, I'm trying to check if the ith bit, that is the bit position in this, is set or not. Okay, if it is set, you have to update the set bit count of that particular position. You have to do +1 there. Okay, as simple as that. So what is that? For example, in this, let us take the example of 9 itself. Okay, so what I'm trying to do here is, so 9 looks something like that, right? 1001. Okay, if I try to do and of this, okay, if I try to do and of this with 1000, so what I will get, see, if the result of this is 1, that means we can conclude that the, okay, yeah, the third index from left is having a 1. Okay, that's what I'm trying to check here, right? See what I'm doing, I'm, this is 9, right? 9, I'm doing and with a number whose, only bit set bit is in the third position. Okay, the third index on the left. Okay, yeah, 0, 1, 2, 3. Yeah, and in this, if it is 1, then the answer will be 1. Okay, that is the basic idea. So now how to write this thing here? What I can do is I can write here like this. Okay, 1, double shift, and by how many times I have to do it? By 1, 2, and 3 times, right? This is what I'm trying to see. Okay, so this 3 will be a parameter for me. Okay, so this will be revolving from 0, 1, 2, 3, 4 till 23. Okay, this 3 is how I'm, going to change it. Okay, one left shift by this particular times. Okay, so when I left shift by one for that particular time, what is happening is it will only check for a particular bit here. Okay, that is this particular bit it is checking now. Okay, for example, if I make it 2, okay, it will check for this bit now, it will check for this particular bit now. Okay, if this bit is 1, the answer will be 1. In this case it is 0, so answer will be 0 here. Okay, so okay, let me read 11 is like 3 only, so it will be checking this bit. If it is 0, answer will be 0. If it is 1, the answer will be 1. So through this we can get to know that which bit is set in the nums. So that's what I'm trying to do. I'm doing num, and I'm doing left shift of 1 by how many times? The number of times is bit position. Okay, if it is non-zero, that means that particular bit is set, so I can update the set bit count of that particular position to +1. Okay, I'm, just doing a +1 there, as simple as that. Okay, once this loop is over, I will have the bit count array ready. What I will doing, I have to return the max of the set bit count, that's max among all the elements of this particular array. Okay, okay, just let me do one thing. I will print and show you if you are not able to catch what I'm saying. Okay, so if you see here, this basically has 24, right? So what I is trying to say here, for example, this particular bit, okay, that whichever bit it refers to, okay, it is 0, that is it refers to a 0th bit. That means all the elements among 2, okay, here have the 0th bit set among 2 of them. Okay, only 2 elements in this have, for which the 0th bit is set to 1. Okay, similarly this refers that the first bit. Okay, that is among all of these, only there are 3 elements for which the first bit is set to 1. Okay, similarly here 4. So this among all the elements, okay, only there are 4 elements for which the 0, 1, and 2, the second bit is set to 1. Okay, something like that. Okay, that is the basic idea. So among them, whichever is the maximum, that will form my answer, right? Because if I do, see, I'm not recording which number it is which are contributing to this. Okay, I'm not recording that, but I know is there are 4 elements. Okay, in this particular array for which this particular bit is set to 1. Okay, this particular bit is set to 1. Okay, so if I do a and of them, that is, if I do a bitwise and of them, I am going to get a non-zero answer. Okay, so this will be my length. Okay, this will form my answer. Okay, if you see here, we have to return the answer. Okay, we have to return the length of the largest such combination. So this will form the length of the largest such combination. Okay, I hope you're trying to get the answer. So in this case, the answer is 4. So any of these could be contributing to the answer. Okay, as you can see here, any of these could be contributing to the answer. Okay, so that's what I'm trying to say. If you see here again, they have given 2 separate answers here, but in the actual, if you see, there could be all of these positions. Okay, whichever element have these positions, they will be having contributing to the answer. Okay, in this case, there are 4 such elements. Okay, so yeah, that is what I'm trying to say. So yeah, fine. Like this is one solution, but here if you see, okay, let me just comment it out quickly. But here I've already submitted the solution and it works. Okay, but if you see here, what we are doing, we are actually taking here. We are setting own array. So we are basically consuming some space here. Though it is a constant space, remember, it will not change with n. Okay, this will not be contributing to the time complexity or space complexity as such, because sorry, space complexity as such, because it is the constant one. Okay, it will not changing with n. That's the first idea. If you talk about the time complexity of this, so what is happening, we are having 2 for loops, I understand that. So basically the idea here is, let us say n is the number of candidates here. Okay, so how much, see, this inner loop is going for n times, for but if here, okay, that is for each number here it is running for n times. So the idea here is, it is 24 into n times. Okay, because for each here it is running, so basically the time complexity will be 24 into n, and again we are doing a max here, it will be again n. So you can say like some constant into n is the time complexity here, because the number is a constant, that is some constant into n, so that complexity will be, because see, time complexity always refers to n only, right? If there is a constant, we have to ignore that constant. Okay, if it is 2 and 3 and 4 n, it doesn't matter, it remains n only. Okay, so the big O of n in this case, the time complexity in big O terms will be O of n only. Okay, and it comes to space complexity, though it is a see a constant space, it will not be part of the space complexity, but still, you will realize that this solution will work slightly slow. If you can avoid this particular thing, it will be slightly faster, but still the time will be over 1 only, because we are not using any space which is dependent on n, okay, as such. So that is the basic thing that I want to tell you. Now this is approach 1. I will show another approach in this. So what is that? See, the only thing that we are trying to eliminate in the first scene, the approach one, what I showed you, this could be avoided. Okay, instead of having a particular array to store this, we can avoid this. Okay, so how to do that, we'll see in the next approach. Okay, so in this, what I'm saying here, I'm just, instead of array, I'm just keeping it as an integer. Okay, max set bit count, I'm setting it to 0. So what I'm doing, see, code is exactly same. Okay, everything is same, but here for each bit position, what I'm taking when I'm entering this loop, I'm setting a set bit count. Okay, so after going through all the elements, okay, I will be updating a set bit count. Okay, so once I come out of this loop, I will be knowing which end now elements are having the set bit count as 1. Okay, for this particular bit. So what I will do, I will take this and I will compare it with this. Okay, so what I'm doing, after I come out of this particular loop, what I will take, I will take the max of the set bit count in this particular for loop what I had. Okay, in this loop what I got, and in any of the previous loop what I got, I will just be comparing them, whichever is the maximum, I will storing in the max set bit count. Okay, and finally I will be returning that. So hope you understood what we are doing here. So see, if you see in the approach, we are finally hitting the max of set bit count, right? So basically we need only the max value, we don't need other values there. Okay, so we can save that particular space. So how I'm doing that, after I come out of this loop, okay, I will be having for that this particular position, basically how many numbers are having the count. Okay, how many numbers are having the bit set. Okay, so this will be the count for that. So once I come out of this loop, I am just comparing that count with any other previous count that I had. Okay, and whichever is the maximum, I will be storing this into this, and finally I will be returning that. So if I can run this and show you, you'll get to see that this works. Yeah. So yeah, fine. That was all for today. This was the second approach. If you talk about the time complexity here, it is the same. If you talk about space complexity, you can probably say it is over 1, because here actually we are not using any other extra space. Okay. So yeah, fine. That was all for today. This was a nice question, by the way, and this was the first time that in this one we are having a question on topic of bit manipulation. You can research more on this. You can go through the basically similar questions topic, and you can see multiple such questions. So often that was all for today. If you like my efforts, please do consider subscribing to my channel. It really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.